yes, I will introduce Nicola to everyone. Huh? Probably all of you know some of the numerous packages that you wrote, like datetime, datetime2, data tools. But you have even more skills than that, as you graduated in mathematics, then did a PhD in electronic system engineering. You wrote a novel. You told me that. Wrote several books for children. Of course, we heard of your books about LaTeX. And even more, you founded your own publishing house to produce your books.
Yeah.
That's really, really impressive. Really a busy life. And today, from what I understood, you will present a solution to properly sort non-alphabetical symbols. So Nicola recorded a video, but I think you will stay with us to answer a question at the end.
Yes, I will. Yeah. Thank you.
Hello, I'm Nicola Talbot. I'm going to talk about bib2gls, specifically looking at glossary entries where the name is a symbol such as a mathematical constant or a pictograph. bib2gls is a command line tool that's incorporated into the document build. It's designed to work with the glossary's extra package, but you will need the record package option. Entries are defined in one or more bib files. bib2gls essentially selects entries according to records found in the auxiliary file in a similar way to bibtec, and hierarchically sorts entries and collates location lists in a similar way to MakeIndex. The development of bib2gls was discussed in Tugboat Volume 40, Issue 1. Selections, cross-references and locations were discussed in Volume 41, Issue 3. Let's first look at a MakeIndex example using the base glossaries package. In this case, we need to use the command \makeglossaries in the preamble. This opens the indexing files and sets up the internal indexing commands. Where you want your glossary to appear in the document, you use \print_glossary. All my entries are defined in an external file called constants.txt, which I have input using \loadgls entries. In my constants.txt file, I define the entries using \new glossary entry. The first argument is the label. It's important not to use special characters in the label. UTF-8 characters should only be used with the native Unicode engines ZLaTeX or LuaLaTeX. The second argument is a comma-separated key-value list. In this case, each name is a symbol representing a mathematical constant. I also have an associated description. Here I've used the symbol key to store the approximate numerical value. You may prefer a different field, but this is convenient for my examples, as the tree group style will show the value in parentheses. The document build is best performed using the MakeGlossaries Perl script. This involves a LaTeX run. In this case I'm using PDF LaTeX, but it could also be the DVI version, or ZLaTeX, or LuaLaTeX. This is followed by the MakeGlossaries invocation, and then another LaTeX run. If you don't have Perl installed, you can use the Lua script instead. Or you can call MakeIndex explicitly, but this is a bit fiddly as it requires remembering all the switches and you need one call per glossary. In my example, I haven't used the sort key, so the sort value is obtained from the name. MakeIndex doesn't recognize LaTeX commands such as \ensureMath or \pi. All sort values are therefore treated as literal strings. Here's my example. All four entries have the sort value obtained from the name key, but from MakeIndex's point of view, we have arrays of literal characters starting with a \, followed by a lowercase e and so on. The first 12 characters are the same in this particular example. so the order is determined by the 13th character onwards. Backslash comes before E, which puts the backslash pi and backslash third first. P comes before S, which puts pi before third. And backslash comes before closing curly brace. So the final order is pi root 2 e to the pi e. The first character of all the sort values is a symbol, the backslash, so they are all placed in the symbols group. Here's the final document. If I switch to using Xindy, I need to add the Xindy package option. The document build is the same if I'm using the Make Glossaries Perl script. Alternatively, I can call Xindy explicitly, but that's again quite fiddly as there are a lot of switches to remember, and again you need a Xindy call per glossary. Let's look at how Xindy orders these 4 entries. Again we have the sort value obtained from the name key, as the sort key wasn't explicitly set. Xindy strips commands and braces, so in the first case we end up with an empty value. For the root 2 we end up with just the digit 2, and for the final 2 entries we end up with just the letter E for both cases. Xindy forbids empty sort values, so the first entry will cause an error. Xindy merges entries that have duplicate sort values. This means that this example won't work with Xindy as it is. The recommendation is that if you use MakeIndex or Xindy and the name value contains commands, then you should use the sort key. In this example, I have set the sort key to pi. The reverse of this applies if you are using bib2gls. Typically, you should not set the sort field in the bib file. Instead, either make use of the different entry types and their fallbacks, or use field aliasing or the sort field resource option. The tex parser library that is incorporated into bib2gls can be used to interpret common commands. This provides a flexible system that allows bib files to be shared across multiple documents that have different sorting requirements. I need to make some modifications to my document to make it work with bib2gls. The first thing I need to do is to replace the base glossaries package with the glossaries-extra package. This in turn loads the base glossaries package and modifies and extends the base commands. You may notice some differences when you switch to glossaries extra, particularly if you have abbreviations. You will also need the record package option if you want to use bib2gls. Instead of \make glossaries and \load gls entries, you need to use \gls xdr load resources, which for simplicity I'm going to refer to as the resource command. In the optional argument, I can specify one or more bib files. If this argument is omitted, the bib file is assumed to have the same base name as the job name. I have also switched off the locations as they're not relevant for the examples. The other change I have had to make is to replace \print glossary with \print unsrt glossary to display the glossary. I now have to create a file called constants.bib, which bears a similarity to constants.tex. But the first thing to notice is that I replace \new glossary entry with @entry. The bib format requires the label first, followed by a comma, and then the key equal value list of fields. These are the same as the tex file, but remember that the values must be delimited in the bib file, whereas in some cases they can be omitted in \new glossary entry. bib2gls comes with a tool that can convert a text file to a bib file. The document build is fairly similar, but instead of using make glossaries, I use bib2gls. You may prefer to use the verbose switch, which will provide additional information in the transcript file, such as the results from using the text parser library. If you want to have letter groups, then you need to use the group switch. This isn't on by default because there are plenty of glossaries that don't require grouping. bib2gls has a concept of fullbacks. A fallback is used when bib2gls requires a value from a field that hasn't been set. If the field has been set, then the fallback isn't required. The bib2gls fallback isn't necessarily the same as the default value used when a key hasn't been supplied to /new glossary entry or /new abbreviation, but quite often it is. The designated fallback for a particular field varies according to the entry type. For example, if bib2gls tries to look up the value of the sort field, but that field hasn't been set, then bib2gls will try the sort fallback instead. In the case of @entry or @index, the sort fallback is the value of the name field. For @abbreviation and @acronym, the sort fallback is the short field. For @symbol and @number, the sort fallback is the label. If the sort field is set, then there's no need to use the fallback. Let's consider constants.bib file, which uses @entry. The sort value needs to be obtained from the sort field, but that field hasn't been set. So the fallback is used, which for @entry is the value of the name field. This gives us the same sort values that we originally had in the first MakeIndex example. These values all contain a /, which means that bib2gls will use the text parser library. This will ignore unrecognized commands, but known symbol commands will be converted to the nearest Unicode equivalent. So in the case of pi, we will end up with a mathematical italic small pi. In the case of e, we end up with just the basic Latin small e. With √2, we end up with a square root symbol followed by the digit 2. Fonts and similar markup are stripped, so the superscript marking is lost. This means the final entry ends up with the sort value consisting of basic Latin small e followed by mathematical italic small pi. There are some cases where the text parser library will use a character from the Unicode subscript and superscript block, but that doesn't happen in this example. The sort method determines the actual ordering. In this case, where we are only dealing with symbols, non-locale letter or letter number sort methods are best, as the locale alphabetical sort methods strip certain characters, since they are designed for words or phrases. In this example, I have used the letter-no case sort method, which is a case-sensitive Unicode ordering. So the final order is e to the pi, √2, pi. Here's the document. The keen-eyed may notice that there's no final full stop after the description. This can be added back with the post-dot package option. There's no group title, even though the tree group style has been used. This is because bib2gls was invoked with the default no group setting. What happens if I instead invoke bib2gls with the group switch? The build process fails on that final LaTeX run with an error from the input-enc package. It's complaining about the Unicode character mathematical italic small pi, which isn't available for this document. The reason why LaTeX has encountered this character is because bib2gls recognizes it as a letter, which it uses as the group title. We can get the document build to work by switching to ZLaTeX or Lua LaTeX and using a font that supports this character. In this case, I've used ZLaTeX with Deja Vu Math Tech Jar, and I can say thank you to Albatross for finding an appropriate font for me. This is the final result. We've actually got 3 groups here. The first is the E letter group, which has all the entries where the final sort value started with the letter E. Then we have the symbols group that contains the entry where the final sort value starts with a character that's not a letter. And finally, we have the pi letter group that has the entry where the final sort value starts with the mathematical italic pi. We can force all the entries into a specific group using the group option. The value of this option must be a label. In this case, I've used GLS symbols, which is a predefined group label provided by the base glossaries package and used internally by both MakeIndex and Xindy. So I can now switch back to PDF LaTeX. This is the result. There is now a single group in the glossary that has the title Symbols, because that is the title associated with the GLS Symbols group label. It's language sensitive, so if you switch the document language, you will get a translated version provided that the language is supported. Now let's try replacing @entry with @number in my bib file, since that's semantically a better entry type for mathematical constants. @number and @symbol entries fall back on the label, not the name field, if the sort field is missing. So the sort values are now the labels pi, e, √2 and Gelfons cons. As mentioned before, labels shouldn't contain UTF-8 characters with PDF LaTeX, but may with ZLaTeX or Lua LaTeX. So you may in this case prefer to use a locale alphabetical sort method. In this case, I've switched to using the English alphabet. This is the result now if I invoke bib2gls with the group switch. There are now 4 letter groups, E, G, P and R, each with a single entry where the first character of the sort value corresponds to the group title. I can specify a different field to use for the sort value. For example, I could use the symbol field, which I have used to store the approximate numerical value. So instead of looking up the value of the sort field, bib2gls will now look up the value of the symbol field in order to determine the value used for sorting. If the given field isn't set, it's the fallback for that field, not for the sort field, that is used. In this case, none of the entry types have a fallback for the symbol field, so the sort value will end up as empty if the symbol field hasn't been set. Since all my symbol fields contain numeric values, it's more appropriate to use a numeric sort method. In this case, I've used sort equals double, which uses a double precision decimal comparator. Numeric sort methods always assign entries to the GLS numbers group, provided the group switch is used, but again you can override this with the group resource option. So now I have a glossary where all constants are ordered according to their approximate value, and they are all placed in the numbers group. As with GLS symbols, the GLS numbers group label is predefined by the base glossaries package and is language sensitive. But group titles can also be changed. The method used with the base glossaries package is to redefine the command where the control sequence name is obtained from the group label followed by group name. But the glossaries extra package provides a group title command where the first argument is the group label and the second argument is the title. But remember that if you are using a language package such as Babel, this may need to go in a language hook. I'm now going to add a second bib file to my example document. This file is called pictographs.bib and contains entries where the name is a pictograph. That is a symbol that's a little picture or icon. In this case, I've used @symbol as it's the most appropriate entry type. Multiple bib files can be specified as a comma-separated list in the value of the src resource option. Remember that if an option value contains a comma, then you must use grouping. The same sort method is applied to all entries within the same resource set. Here's my modified document. I've had to add the package marvosim, since I now have entries that use commands defined in that package. I also need to add pictographs to the list of bib files. Note that I've removed the sort-field option and switched the sort method back to letter-no case. Again, I haven't set the sort field for any of the entries in the new bib file. As I mentioned earlier, the fallback for the missing sort field is the label for both @symbol and @number. So the final order is the case-sensitive letter order of the labels: club suit, diamond suit, email, envelope, gelfonscons, heart suit, landline, phone, pie, root to, spade suit. I haven't used the group switch, so there's no grouping. The resulting glossary is a bit of a mixture, and the order isn't particularly intuitive to the reader. For example, telephone comes between heart and mobile phone. It's possible to change the sort field fallback used for particular types of entries. There are resource options associated with particular classifications of entry types. For example, both @symbol and @number have their sort field fallback determined by the resource option symbol-sort-fallback. This is a far more flexible way of changing the sort value that won't affect other types of entries. In this example, I've changed the fallback to the name field. This means I once again have sort values that contain LaTeX commands, so the text parser library is used. The current version doesn't recognize marvosim commands, although it's possible support may be added later. Unknown commands are ignored, so the marvosim commands will expand to nothing when the sort value is pre-processed. But bib2gls doesn't mind empty sort values. However, it's important to remember that fallbacks are only used if the required field isn't set, not if the value ends up empty after pre-processing. Duplicate sort values are ordered relative to each other according to the identical-sort-action option. The default is a non-locale case-sensitive letter ordering of the entry label. Since labels must be unique, this ensures an exact final order. Here are my constants and pictographs, where the sort value has been obtained by falling back on the name field. The constants are all as they were in the earlier example. The card suit commands are all recognized by the text parser library and have been replaced by the most appropriate Unicode characters. The marvosim entries have all ended up with empty sort values. The letter-no case sort method puts empty sort values at the start. Other methods may treat empty values differently. For example, the numerical sort methods treat an empty value as 0. So email, envelope, phone and landline will all go at the start of the list. But their relative order is determined by the label, so we end up with email, envelope, landline, phone. This is how the document ends up, with email, letter, telephone and mobile phone right at the start, followed by 3 other constants, the card suits, and finally the mathematical italic small pi, which has the highest Unicode value. The symbol -sort -fallback option governs both at symbol and at number, since they belong to the same class of entry used to represent symbols. But what if I want to separate my examples out so that I have the pictographs ordered by their description and constants ordered by their name? I can still use symbol -sort -fallback for at symbol, but I can override this setting for at number with the custom -sort -fallbacks resource option. This option takes a key value list where the key part is the entry type without the leading at symbol and the value part is the field to use as a sort field fallback. So here I have used number equals name to indicate that at number entries should fall back on the name field. Since descriptions contains words or phrases, the non-locale case-sensitive letter sort is no longer appropriate, so I'm going to use the English alphabet sort method instead. Now my pictographs are ordered by their description, but the constants are ordered by their name. It might look better to have the pictographs ordered by their descriptions in one group and the constants ordered numerically by their approximate value in another. This can be achieved by using multiple resource commands. The entries will all be placed in the same glossary, but the glossary will be split up into groups, each group corresponding to each resource command. I've used the group option to assign the group label for that particular resource set. The groups will be in the same order as the resource commands. Remember that bib2gls needs to be invoked with the group switch. Now I have a glossary split up into a symbols group and a numbers group, where the symbols are ordered by description and the numbers are ordered numerically according to their approximate value. There are other approaches. For example, you could use separate glossaries, or you could use hierarchical entries, which would require defining parent entries. There are some additional examples that can be found in the Dickymore Books gallery at dickymore-books.com/gallery.
Thank you for this very interesting and detailed tutorial. Does anyone have questions?
Yeah, I've got a question. If I was writing it in Python, which is the language I'm used to, I'd expect the whole process to have 2 parameters. One is a function that from an entry computes the corresponding sort key. And then the other would be a function that from an entry computes the corresponding rendering, which might be LaTeX. So the package itself, the management tool, could be customized by providing sort key and rendering. Now, if you focus on the sort key, all the various things that you put on the command line are different ways of specifying what the sort key is. Oh, by the way, the result of the sort key should possibly be passed to the rendering function along with the entry, which would allow grouping to take place. Now, I'm just wondering, why this architecture, which seems to me obvious from a point of view of a Python programmer, isn't adopted in the world that you're working in.
Or no, I mean, bib2gls doesn't know how things are going to be rendered, because some things can be rendered in a fairly complicated manner. Not everything, not every sort of pictograph has something that's intuitively in a sort of alphabetical sense. It is actually possible to define your own custom command that you can put in your bib file that only bib2gls sees. So bib2gls can obtain a different sort value. So one example would be if you have entries where you want to sort, where the entry starts with an article such as the or a. So for example, let's say your bib entry is book titles. So one of them could be The Lord of the Ring or The Hobbit, let's say The Hobbit. You might want that to be sorted under H, but you would actually want it to appear in the list as The Hobbit rather than Hobbit the. So what you could do is create a command that takes two arguments, the article and the rest of it. And you can present BibTeX with a definition of the command that puts the article last. But LaTeX will see a different version of the command where the article comes first. So you can do it that way.
I think we might be looking at things in slightly different ways. What I'm thinking is that instead of having lots of options to the big function, you have a sort function, and that might have lots of options.
Well,
And that's important, because if you're able to pass the function, you're, so to speak, making the API as simple as possible as far as the thing that you're writing. And I think it's coming down to some sort of architectural forces and habits. But let me take a different view of this, which is that in an online setting, think of shopping. So I might say, I'm interested in potatoes, and I want the key to be the price, and I want the cheapest first. And there it's clear that the user is actually creating its own key, a custom key. When you do that, you're creating a custom function that determines what the key should be. And it seems that your approach, and the widespread approach, is to add another field to the data.
well, in this case, you're not particularly adding another field, because you're not setting the sort field. You're trying to determine the most appropriate sort value from all the fields that are actually present that will need to be there in order to typeset the document. But I think it's also important to remember that a lot of LaTeX users aren't actually programmers, so they're not really used to the idea of creating functions in order to sort things. So I did try and go with a sort of more intuitive option list for non-programmers, sort of the sort of average LaTeX user. I hope I've managed that, but it's always difficult to tell what the average user of any software is.
I'd like to thank you for your talk. I'd like to thank you for your talk, Nicola. I found it very interesting.
Thank you.
Frank has a question.
Yeah, quick question on a technical side. Very early on, you said something like, not sure exactly, I think on the label, that you cannot use UTF-8 characters if you're running with PDF tech. Is that because you're putting those at some point in your code into CS names? Because since, I don't know, 1 or 2 releases back, PDF text should behave pretty if you do this. For example, these days you can put UTF-8 characters into reference label and ref commands without any problem. So my guess is this would work with your code as well, if that's the reason.
It might do now. I haven't really investigated since the LaTeX kernel changed. I do know that beforehand, and I suppose there are a lot of people who are still using old versions of LaTeX.
I just wanted to point that out, that this is nowadays a possibility.
Yeah, it's something I've been meaning to sort of investigate to see if it does work or not. So I always sort of fall back on saying that, because that's all I used to have to say in the past.
I know it takes a couple of years to get used to, but I mean, on labels, it was so many people wanted to have sort of their language being represented in labels, so we tried hard to make that possible, and I think that is exactly the same problem you have there. And so it should work nowadays.
The only thing I think to be careful is special characters, so like putting a tilde in or something, or a hash or something like that. I think that I would
those, if it is syntax character, it would still be a problem, but normal UTF-8 should work, I would assume.
I'll give it a try. I mean, obviously special characters will be a problem for ZLaTeX and Lua LaTeX as well. But yes, that's a very good point to bring up. And I will investigate that.
Okay.
Thank you.
Are there other questions? I'm really impressed about the flexibility of bib2gls and the way you sort things. But is it usual to have, in, for example, mathematical books, to have a lot of symbols in the index?
I don't know. There are some where you can have basically a huge list of tables of functions, sort of like an enormous compendium. So I suppose that might do. But to be honest, I don't really use that very much these days. I don't really do too many typesetting of mathematical documents anymore.
I'm asking because as a naive reader, I expect an index to help me find things, and having an index with symbol, when I can have a look at all the symbols at a glance, that's okay. But if it's on 2 or 3 or 7 pages, it's useless.
Yeah, but the other thing I was sort of thinking about in terms of the pictographs is if, for example, you have a map with symbols on it, you might want to have a key, so you could use it for that as well. Sort of, it's quite flexible.
It's very flexible, yes.
Can I show you a couple of maths books? This one is notation, and there's a lot of it. Sorry.
Stay like that for a few seconds so people can zoom on your screen.
It's 2 pages, 2 columns, a lot of notation. And I think this is another book.
Could you show it again, Jonathan? So people can zoom on your screen while you're holding the book.
Oh, sorry, I've only got one pair of hands.
Yes.
I've no idea what the sort order is. Fortunately, I'll just go up a bit. Fortunately, it only spans 2 pages.
That's already a lot. Huh?
It's already a lot. I'm glad that I'm sighted rather than blind, because if I was blind, I'd find it really quite difficult. And it gives page references, presumably to the area, and it breaks it into 2 groups: algebraic geometry and intersection theory. And here's the book if you want. It's the Bible of the subject.
Yeah, well, if you want to have the back references, the location numbers, then you can do that. I switched them off for all the examples because all the examples would have just had page 1 as the location, but it is possible.
Yeah, I was just sort of showing how it's used in practice.
Yeah.
I've also seen papers that have an index of notation at the beginning.
Yeah, I think my PhD thesis had one as well, but that was just used. I think that was back with the old LaTeX 209. So I think that was just a tabular environment or something like that. That was a long time ago.
My PhD was typed up by technical typists on IBM golf ball typewriters. So any mathematical symbol was a great luxury. Thank you again for your talk.
Thank you.
We still have a few minutes for comments or questions for Nicola. Okay, if no question, we have a very short break of 5 minutes. Nicola, thank you for your tutorial. I will look at your work and try it. I will also try to sort colors, for example.
That's great, thank you.